Hello friends, welcome to my channel. Let's have a look at today's challenge problem. Problem 695, maximum area of island. So for this problem, we're going to share a solution based on the disjoint set data structure. So the problem asks us to return the maximum area of an island in the grid. If there's no such island, return 0. So in example 1, so the return is 6, and the largest island consists of 6 ones. So the size is 6, which is depicted in the deep orange color here. So in example 2, so the return is 0, so which is sort of a trivial example. So in the constraint, the m and n is bounded above by 50, so which is not a very large number. So with that said, let's look at the method here we're going to share. So we'll practice the disjoint set data structure, which is very natural to this problem. So the idea is the following. So we shall group all the ones that are 4-directional connected together to form an island, so which corresponds to cluster. So in the disjoint set setting. So we just need to return the largest cluster size if there is. So otherwise we return 0. So that's the idea. So it's also actually the process. So basically in practice we're going to use the find method to create island, use union method to merge islands to form a larger one. So before we share the code, actually this problem can be solved using traversal method by standard breadth first search or depth first search. So it's also good to have a try. So with that said, let's first implement a class called DSU, and then we're going to apply the class, the data structure to the problem here. So first I'm going to implement an DSU. So this is actually very standard. Let's do it quickly. So the initialization, so self. So I'm going to initialize that using self roots and self rex. The root will store the node parent relationships, and the rex will store the root, the node and rec relationships. So with that said, we're going to implement the union, the find method. So we're going to accept a position. So here the position is like, for example, a coordinate like RC in this problem. So first I'm going to consider a case that is the position not in the data structure yet. So position not in self roots. Then in this case we're going to add it to the data structure and use the natural sets. So for example, the rec will be 1, corresponding to 1 position cluster. Then we're going to return this position. Otherwise, we're going to do a while loop to retrieve the root. So I'm going to introduce a variable called result, which is the position at the very beginning. Then we're going to check if result does not equal to self roots result. Then for this, basically we're going to set the result to be its root, and then we do the while loop. After we exit the while loop, we're going to have a state that result equals the root of result. Then we just need to return the result. So typically we can do a path compression here. So basically we set the roots of the result. So here is the result by its root. So let's copy it and then apply the self roots again. That's it for this find method. So here we are implementing a find with path compression. So next let's do the union. So it's self and position 1, position 2. So first we're going to find the root of these 2 positions. Let's self find position 1. So now let's copy this one. Self find position 2. And then basically what we want to do is check if root 1 and root 2 are in the same cluster. If so, we do nothing. Otherwise, we reset the roots. So if root 1 does not equals to root 2, we're going to retrieve the rect information and then set the root. So if self rect root 1 is greater or equal than self rect root 2, then we are going to set the root of root 2 to be root 1, and then we increment the size of root 1 by that of root 2. So here let's copy and make modifications. In other case, we're going to do the same thing, but we just do it in the reverse direction. So we're going to set the root of root 1 to be root 2, and then increment the root rect of root 2 by that of root 1. So that's it for the union operations. Here we implemented the union operation with union by rect. So for our problem here, because we are going to track the largest island size, let's make a simple help function. Let's see, get islands or get clusters. So the cluster corresponds to a island. So I'm going to initialize an empty dictionary and then iterate over the data structure. So self roots items. Then first I'm going to find the root. So that is self find the root of v. Then basically we check if root in D or not. If root not in D, we're going to set the value corresponding to this root by a single element set. Otherwise, we're going to add the current key to the set. So that's it. So we're going to return D. So D is a dictionary representation of the islands. So with that said, we are ready to attack the original problem. So what we are going to do is that we traverse the grid, and then if we find ones, we just add to the data structure. If the neighbors have ones, we're just going to merge them. So let's look at a specific procedure. So first, I'm going to instantiate a DSU object. So then we're going to track the information for the from the grid. So this is the routine. Next, we're going to traverse for I in range M, for J in range M. First, we're going to check if grid ij is 1 or not. If it equals 1, so we're going to first add this position to the data structure. So it's DSU find this ij. So this is one step. The key step is to check if its neighbors are already in the data structure. If so, we're going to merge. So let's check the neighbors for position in the neighbor, right? So the neighbor is I minus 1j, I plus 1j, and I j minus 1, and I and j plus 1. So if the position in DSU roots, then it means it's a 1. It's inside a cluster or island. Then we're going to do the union operation, DSU union. So union ij with this position. So that's all the main work we need to do. So if you make a comparison with the breadth first search, so this is a step here. So now let's get the clusters or islands. It equals DSU get islands. So this is the function. So then we're going to prepare the return. the return is the largest island size, right? So for this, we're going to set a result to be 0, because if there's no island, we're going to return 0. Then we're going to iterate the islands and then get their size. So for v in islands values, so each of the v corresponding to the actual islands, so we just need to reset the result to compare with their size, right? So maximum result and the size of this v. So that's about it. So now we are ready to return the results. So that's the full solution. So once we have the data structure DSU, then the solution to this problem is just a traversal and a check. Then we're going to do a special case check. DSU takes the 0 position variable, where DSU 65. So here, and DSU gets island. So here I'm missing a self. Let's do it again. Yeah, it passes the first example. Let's try second example. Let's try first example. Yeah, it passes example 1. Now let's look at the generic case. Yeah, it passes the generic case. So I guess that's about it for this solution and for this video. Thank you very much.